Various goal-directed tasks involve every day of our life. The performance is determined by how much connected efforts we exert on the task. The level of the exerted effort has found positively related to the pupil dilation. However, this measurement usually be done by a night checker. The biggest drawback of a night checker is the expensive cost. This project aims to develop a real-time pupil detecting software program using an RGB camera, then evaluates the program by conducting a user study for connected effort examination. The embedded task is used as the user study task. The program is divided into two parts, the pupil detection and the embedded task. The idea is that iris and pupil have a close center point, and the size of the pupil will never larger than the size of the iris. So before finding the pupil, we find the iris and use the iris to map the pupil. The detection is the procedure of image processing. It first detects both eyes, then it chops the eye images and transforms to grayscale. The next step is blur the image to reduce the noise. After that, it converts the images into binary image. This is the crucial step to distinguish the iris. To do that, we simply apply a threshold, so every pixel value above that threshold turns to white and the value below turns to black. After one more denoising step, the program finds the contours and enclosing a circle with that center coordinate and radius. Detecting pupil is similar to the irises, but there are more steps. After the grayscale, the program adjusts the image contrast by equalizing the image histogram and reduces the noise. The thresholding technique here is threshold inverse. The program might find more than one contours. Therefore, the next step is filtering and find the one which is most likely to be a pupil. We take the center coordinate and the radius of the iris and compare with the contours that we find here. The one with the radius smaller than the iris's radius and has the closest center coordinate to the iris's center will be selected as the pupil. The program also counts the blink. User study conducted with the embedded task. It contains 4 difficulty levels from 0 back to 3 back. The task is to identify if current alphabet is the same as the one at n12 back. The user presses the keyboard to input the answer. The timestamp of the mistake will also be recorded. The program is developed using Python 3.7 version and the DLib library for face recognition, an OpenCV library for image processing. Thanks for watching and hope you enjoy the video.